To simplify a complex fraction, I'm going to multiply each individual numerator by the least common denominator of all the pieces. And so let's go ahead and build the least common denominator as we've done in the past by looking at these three individual fractions within this fraction. If you need help with building the least common denominator, go back and watch one of my previous videos. I can show you how to do that. So my least common denominator, I'm going to need the x. I'm also going to need the x plus 4. And so what I'm going to do, unlike what I've done in the past when I've multiplied, or when I've tried to add two fractions together, I'm going to only multiply the numerators by the least common denominator. So next to each numerator of the complex fraction, I'm going to put my LCD x times x plus 4 next to all three pieces. If it helps you, put that x times x plus 4 over 1 to remind yourselves that you're just doing the numerators times this. Now watch what's going to happen, and I want you to kind of spotlight this problem and just look at one piece of it at a time. So kind of spotlight right here and take a look just at those parts right there. When I multiply, since I have the same thing in the top and bottom, those x plus 4 pieces will cancel out. Multiplying a number or a group of fractions by its least common denominator will have the effect of eliminating fractions. And so all that's left in the numerator is just 5x, 5 times x. No more fraction within the fraction. Let's go ahead and do the same thing with these pieces on the bottom. So again, let's spotlight and just look at this piece of the problem right there. I can see the same thing in the top and bottom is that x plus 4, so those will get eliminated, leaving behind just 1 times x, or just x. And finally, one more time, I'm going to spotlight and just look at this part of the problem right there. This thing I see the same on the top and bottom are those x's. If you do this and there's something left over, there's a fraction left over, you've done something wrong. All your fractions should be eliminated. For this final portion, I need to distribute and do 2 times x plus 4. So I end up with plus 2x. And then plus 8. So I've done the main part of the problem. I've eliminated the fraction within a fraction. To finish this, I have a few like terms I can combine in the denominator. So I'll go ahead and do that. So I get 5x over 3x plus 8. Now I cannot cross those x's out because I've not factored, and in fact the denominator won't factor, although I should try to do that. If there's something that you could factor that would result in something else being simplified and canceled out, you have to do it. In this case, that's as much as I can do. Let's take a look at one more complex fraction in this example. This time all of my denominators, the 6, the 3, the 5, and the 10, all of them are numerical. So I need to find the least common denominator between all 4 of those numbers. And it turns out the LCD between 6 and 3 and 5 and 10, the multiple they all have in common, is going to be 30. And so once again I'm going to go through and multiply just the numerators by my least common denominator. So each numerator, and if you want to, you can write this 30 over 1 to remind yourself you're just doing the top times 30. Multiplying something by its least common denominator will have the effect of eliminating fractions, which is what I'm trying to do. I'm trying to get rid of them. So it's going to play out a little bit differently than last time. For example, in this first piece right here, if I spotlight right here, 30 and 6 don't get eliminated completely, but if I think of this as 30 divided by 6, what's left behind is just a 5. That 6 denominator will cancel out, but it'll leave behind 5x. So I've got that for the first part of the problem. Moving along then and spotlighting the next part of the problem, if I look right there, 30 over 3. The 3 will get eliminated and leave behind just a 10, so I've got minus 10x when I multiply those remaining pieces together. Moving to the denominator of this complex fraction, looking at this piece right here, I've got 30 over 5, so that'll cancel out to just a 6. So a 6x when I multiply those pieces. And finally right here, 30 over 10 leaves behind just a 3. So negative 7 times 3 is negative 21. Once again, I've done the main part of the problem. I've eliminated the complex fraction, but let me go ahead and simplify what I can. The numerator has like terms in it, so I'll make that a negative 5x. The denominator, I can't subtract 6x minus 21. They're not like terms. I could factor that, though. There is a 3 those have in common. So if I can factor, I might as well try to do it just to see what happens. I can pull out a 3 and leave behind 2x minus 7. Unfortunately, nothing can still be factored. There's nothing that can be crossed out. But I wouldn't know that until I tried it. So it's worth always factoring if you can. Real quick, I have some people ask me, well, is that the answer, or could I have left it as 6x minus 21? Well, because nothing was able to be canceled out, either of these answers are a-okay. Neither one is more simplified than the other, so either answer is fine, but it's always worth trying to factor, because if you can factor and cancel, you have to factor and cancel.